Welcome to Algebra II, Week 11. Despite the fact that this says Algebra II Honors, these notes will be used for Algebra II as well. So please remember, I know sometimes students do not necessarily look at these. Please remember that this is also going to be used for my regular Algebra II as well. Okay, so moving right along. Don't forget to fill in your table of contents. Complete your warm-up for the week. I apologize for the messiness. There are 10 questions for your warm-up, so please make sure to do those. And we're going to be reviewing how to factor trinomials, 4 or more terms, difference or squares, and we're going to learn how to factor a sum and difference of cubes. Okay, so I want you to remember that to factor a trinomial, the first thing that you should look for is the greatest common factor. Looking at question 1, these 3 terms do not have a greatest common factor. So I can say that A is equal to 1, B is equal to -3, and C is equal to -40. I do expect you to make your table factors of -40 that will give me a sum of -3. My honor students may know how to do this because of the summer work that we had done, but I know this might be the first time for some of my regular Algebra 2, so I'm going to teach this like I would any other time it's something is new. So I want factors of -40. Things that multiply to give me -40. 1 times -40, -1 times +40. 2 times -20, -2 times +20. I am looking for a sum of -3, so if you find that sum, you can stop. But again, I do expect this chart to be shown, and please do not use PhotoMath. PhotoMath will not give you this chart. It will only give you the final answer, so please try to learn how to do this on your own. 3 will not divide evenly into 40. 4 will divide evenly into 40 10 times, so 4 times -10, -4 times +10. 5 divides evenly into 40, 5 times -8, -5 times +8. Now what do I mean by a sum of -3? That means when I add those two factors together, will I get -3? And I don't expect you to go down through here and do all of these. 2 plus -20 is -18. -2 plus 20 is +18. 4 plus -10 is -6. -4 plus 10 is 6. 5 plus -8 is -3. That's what I want. I want -3. The next thing that I do, I need to put my 2 parentheses because this trinomial was created from multiplying 2 binomials. The next thing I have to do after that is to put my middle variable in this spot and this spot, just the variable, not the coefficient of that variable. And then I need to put that middle variable. Then I need to look at my factors. I have a +5, so a +5, and I have a -8, so -8. That means that x squared minus 3x minus 40 would factor into x plus 5 times x minus 8. Again, I want to reiterate the fact that I expect to see A, B, and C named. I expect this chart over here, and I expect this final answer to be written out. So please make sure that you have all of those things done in order to earn full credit on your assignment and any assessment that we do. Now let's go on to number 5. No, let's not go to number 5. Let's do number 2. Looking at number 2, do I have a common factor? Do 2g squared minus 3g minus 40, do they have a common factor? No, they do not. So I can name my a, b, and c value. A is 2, b is negative 3, c is negative 40. The next thing I'm going to do is make my chart over here on the side. I want factors of a times c. A times c. 2 times negative 40 is negative 80. And I want a sum of b. b is negative 3. Factors of negative 80 that'll give me a sum of negative 3. What are those factors? 1 times negative 80, negative 1 times positive 80. 2 times negative 40, negative 2 times positive 40. 3 doesn't go into 80. 4 times negative 20, negative 4 times positive 20. 5 goes into 80 16 times. 5 times negative 16, negative 5 times positive 16. 6 does not go into 80. 7 does not go into 80. 8 goes into 80 10 times. 8 times negative 10, negative 8 times positive 10. And then do any of those give me a sum of negative 3? None of those factors give me a sum of negative 3. So that means that number 2 on this page is not factorable. This does not happen very often. I like to make sure that all of the problems that I give you to factor will indeed factor. Looking at number 3, I do notice that I have a greatest common factor. 3 will divide into each of these evenly. So I'm going to divide them by 3. But remember, factoring is undoing the distributive property. So I need to make sure to have something where I'm distributing the 3. 3v squared divided by 3 is v squared. Negative 24v divided by 3 is negative 8v. Negative 27 divided by 3 is negative 9. And now I'm ready to name my a value, my b value, and my c value. A is 1, b is negative 8, and c is negative 9. So can I find factors of a times c that will give me a sum of b? A times c would be negative 9, b is negative 8. Factors of negative 9. Negative 1 times positive 9. If I add those together, I get positive 8. Positive 1 times negative 9. If I add those together, I get negative 8. So that is what works. Using the same method that I used for number 1, I'm going to bring down my 3 first. It has to be in my answer. I'm going to put my two empty variables, or my two empty binomials. I'm going to put the middle variable in the first spot of each of these. That middle variable is v. And then I'm going to put a plus 1 because that's positive 1. And I'm going to put a negative 9 because that's a negative 9. And so the answer is 3 times the quantity, v plus 1, times the quantity, v minus 9. Now looking at number 4, I do notice that I have a common factor of 5. 5 goes into 15w squared, 3w squared times. 5 goes into negative 25w, negative 5w times, and 5 goes into 10 2 times. Now I don't have space, that's why I didn't divide by 5 like I did in question 3. But if you want to show that dividing by 5, you're more than welcome to. Now I'm ready to do A is 3, B is negative 5, and C is 2. I need my chart. I'll do it over here on the left. A times C is 6. Sum of B is negative 5. and factors of positive 6. Positive 1 times positive 6, or negative 1 times negative 6. Positive 1 plus positive 6 is 7. Negative 1 plus negative 6 is negative 7, so that won't work. Positive 2 times positive 3. Negative 2 times negative 3. 2 plus 3 is positive 5. Negative 2 plus negative 3 is negative 5. So that last pair is what works for me. Now, since my A value, I'll highlight that, since my A value is not 1, I cannot do it the same way I did number 3 because that A value is 1, and number 1 because that A value is 1. There are several different methods, but I would like to see you use this method. It may take a few more steps, and I'll have to find some space to finish the problem because I won't have space. I know that I'm going to do this. Let me go back and grab my pen. I'm going to take the answer to number 4 up here. So my final answer will be up here at the top for number 4. Okay. What you do is this. You keep your first term, 3w squared, and your second term, plus 2, the same. Your middle term, let me grab a highlighter again, this negative 5w will be replaced with negative 2w and negative 3w. That's what you do with this. So you have to do a couple more steps when you're doing a trinomial where a is not 1. So negative 5w will be replaced with negative 2w and negative 3w. Okay, I'm going to continue the problem here. The next thing that I do, I'm going to group the first two terms together using parentheses. I'm going to put an addition sign and group the second two terms together using parentheses. I'm going to look at my first group. This first group here, 3w squared and negative 2w. Do they have a common factor? 3 and negative 2 do not have a common factor, but w squared and w do have a common factor. That common factor is w. So I'm going to put a w on the outside of the parentheses. I'm going to divide both of these by w, and you're welcome to do that mentally. 3w squared divided by w is just 3w. Negative 2w divided by w is negative 2. In the next grouping, if you notice, negative 3w and 2 really have nothing in common. Negative 3 and positive 2 do not have a common factor besides 1. There's a w on the negative 3w, but not a w on the 2. So it appears like I can't do anything there. But here is a rule that you need to remember. If this first term is a negative, you must factor out a negative 1 in order to have this in the proper form. Negative 3w divided by negative 1 is positive 3w. Positive 2 divided by negative 1 is negative 2. Now, how do you finish this? What you're looking for is this. Let me first say something else. This and this are the two terms of my problem. This is a binomial. Two terms separated by a subtraction sign. When I look here, this part of the first term and this part of the second term are the same. And that's what you want. You want those to be the same. So how you finish is, and I'll go to the very top to put the answer. You take what they have in parentheses that's the same and put it in one of the binomials. It does not matter which one. And then what you do is you pretend like this isn't here. What's left when you take that away? W. So you put that in the first part of your second binomial in your answer. Look at your second term. You take away the 3w minus 2. What's left when you take away the 3w minus 2? Minus 1. So if I were to multiply out those two binomials and that constant of 5, I would get 15w squared minus 25w plus 10. That would be the answer. I hope that makes sense. We have a few more grouping problems. Number 5, number 6, and number 8 are grouping, so hopefully that will help you get the hang of it. Okay, let's move on to number 5. If you notice, number 5 has 4 terms. There are 4 terms all the way through here. So that means that I can't factor using a chart the way I did for number 1, 2, and 3, and 4. What I would do is first, do check all 4 terms. Do they have a common factor? No, they do not. So I'm going to group the first 2 terms together using parentheses. I'm going to put a plus sign. I'm going to emphasize that. Put a plus sign. Group the last 2 terms together. The first 2 terms have 5. 5 and 10 have 5 in common. They both don't have x, so I can't use x, but they both do have y. So 5y is my common factor for my first term. I'm going to divide both of these by 5y, and you can do that mentally again. 5xy divided by 5y is just x. 10y divided by 5y is positive 2. For my next group, I have negative 4 as my greatest common factor. They both don't have x, so I can't put x in my greatest common factor, but both of them are negative, and both of them are divisible by 4, so my common factor is negative 4. I can put plus negative 4, but I can go ahead and put minus because I would want to rewrite that anyway. And I'm going to divide both of these by negative 4. I'm going to have positive x plus 2. I always ask students, did it work? Did this work? And how do you know? You're looking for this binomial and this binomial to be the same. All the ones that I give you, I want them to work, so if they don't work, either you've made a mistake or I've made a mistake. So let me continue and look at the final answer for this one. What I will do is this. I will write down what they had in common. Then in parentheses beside of it, I will take away what they had in common from the first term. Then I will take away what they had in common from the second term. And then that would be my final answer to factor number 5. Okay, let's factor number 6. Group the first 2 together. Put a plus sign, group the last 2 together. My first 2 terms both have a 3, but they do not, I left off something. I almost made a mistake. Look at that. Okay. They both have 3 in common. This has m cubed and this has m. So that means I need to factor out 3m. That is my common factor. So when I divide both of these by 3m, I am left with 3 divided by 3 is 1. M cubed divided by m is m squared. Negative 3 divided by 3 is negative 1. M divided by m cancels out. I'm going to bring down my plus sign. This group has 2 in common for sure. I see the 2's. And they do both have n. So 2n is my greatest common factor for that second binomial. Then when I divide them both by 2n, 2mn divided by 2n is m, and negative 2n divided by 2 is negative 1. And let's see. It appears that this one does not factor either. Did I make any mistakes? I don't think I did. So what that means is, and I'm glad it didn't factor, I believe that I should have put an m squared on this m right here. for it to factor, but I'm so glad it didn't. This happens sometimes. There are times when you group things together like we did here, and when you get down to here, if you've not made any mistakes, and I don't believe I've made any mistakes mathematically, but if you've not made any mistakes and you get to that point, then that means that it's not factorable. So number 6 here is not factorable. Let me know if you disagree, because I could have made a mistake. I was distracted by someone delivering a package, so that's okay. All right, let's look at number 8. I want to do number 8 first, and I'm going to erase so I'll have space to do number 8. When I look at number 8, though, before I even started, I noticed they all have 4 as a common factor. I'm going to go ahead and take out that 4. Oops. Okay, I'm going to take out the 4, divide each of those terms by 4, x cubed plus x squared minus x minus 1. Then I'm going to keep this 4. I'm actually going to carry this 4 over here to my answer so I can forget about it. And I'm going to do grouping with this. So I've forgotten about the 4 because it's in my answer. I'm ready to keep it there. And I'm going to group the first 2 terms together and the second 2 terms together, put a plus sign in the middle. The first 2 terms have x squared in common. When I divide them each by x squared, x cubed divided by x squared is x. X squared divided by x squared is plus 1. And the second group, they don't have a numerical common factor besides negative 1. Negative x divided by negative 1 is positive x. Negative 1 divided by negative 1 is positive 1. Did it work? Have I done it properly? Did I type it properly? Yes. This term and this term are the same. I do notice something, though. I don't have my final answer, and I'll point that out in just a moment. I'll write down what they have that are the same. And then if I get rid of what's the same, I have x squared minus 1. Now that I look at this, x squared minus 1 is not completely factored. We learned that this is a difference of squares. So I need to factor my difference of squares. I'll bring down my 4. I'll bring down my x plus 1 because it is completely factored. I'll put 2 empty parentheses, one with an addition sign and one with a subtraction sign. I'm going to take the square root of x squared and the square root of 1. And I do expect to see that work. The square root of x squared is x. The square root of 1 is 1. And now that is the final answer to number 8. Let's try number 7. It's not grouping, that's why I wanted to save it for last. It's a binomial. So 1 through 4 are 3 terms, 5, 6, and 8 are 4 terms, and now number 7 is 2 terms. I do have a greatest common factor of 8, so I'm going to go ahead and divide 8 away from both of those terms. Let me say 8x to the 4th divided by 8 is x to the 4th. Negative 32 divided by 8 is negative 4. And now what I will do is I will look at this binomial. I do see a subtraction sign, and I do see 2 perfect squares. So I do know that I have a difference of squares. So I'm going to go ahead and bring my 8 down, put 2 empty binomials, one with a plus sign, one with a minus sign. And then I'm going to take the square root of x to the 4th, and that's x squared. That goes in the first spot of each of these. And I'm going to take the square root of 4, and that is 2, and that goes in the second spot. I want to reiterate the fact that I expect to see on your paper this right here. I expect to know that you are thinking and knowing that this is a difference of squares. Photomath does not do that for you, so please remember that But if you want full credit, you need to make sure to be going through this thought process on your own, not without the aid of photomath. Now, as I look at these two binomials, this is a sum of one perfect square and one non-perfect square. And this is a difference of one perfect square and one non-perfect square. So that means that this one is finished and completely factored. The answer is 8 times the quantity x squared plus 2 times this quantity x squared minus 2. We'll move on to the next page. Now we're going to do a sum of cubes and a difference of cubes. Now we're going to learn how to factor a sum and difference of cubes. And this form of factoring is the one that is really primary to Algebra II. The other forms of factoring, besides the more complex polynomials we'll get to, those were intended to have been learned in Algebra I. So I know that we don't always get there in Algebra I, honors we do, but in our regular Algebra I we don't always get there. But it was intended for you to learn that basic trinomial factoring and basic binomial difference of squares factoring in Algebra I. Okay, so continuing. I have written the steps that you need to follow over here on the right. These are your steps. As usual, the first thing you do is look for a greatest common factor. Let's do that on each of these. Number 1, there's not a greatest common factor. Number 2, there's not a greatest common factor. Number 3, there is a greatest common factor. Both of these are divisible by 5. Five y cubed divided by 5 is y cubed. 1,000. 5 goes into 10 two times. Bring down your 0. 5 goes into 0 no times. And 5, bring down your next 0. 5 goes into 0 no times. So that's 200. And number 4 does have a common factor, and that common factor is 3. When you divide each of these by 3, 3m cubed divided by 3 is m cubed. Negative 3 divided by 3 is negative 1. Okay, so I've taken out my greatest common factor. I did that for all of those. The next thing, PC with a question mark. That means, do we have a perfect cubes in this problem? Are these perfect cubes? I should have added in my list up here variables that are perfect cubes. X cubed is a perfect cube. Y cubed, any of those. Z to the 6th power, that's a perfect cube. H to the 9th power, that's a perfect cube. If you'll notice, these are all multiples of 3. Exponents that are multiples of 3 are perfect cubes. So let's look through all of these quickly. Do I have both of them perfect cubes? Are my variables perfect cubes and my numbers? Now, to be perfect cubes, let me show you from my list. You should see these numbers, that I'm highlighting in yellow, in your problem. So let's go look. Number 1, x cubed and 1. Ignore the minus sign. X cubed and 1. They're both in those lists over there to the right. Number 2, 8, g to the 3rd. G's not there, but an exponent of 3 is, so it's okay. And 125. Yes, they're all over there. Number 3, I look at what I have when I've taken out my greatest common factor. Inside the parentheses, y cubed, that's okay, but is 200 in this list over here? No, 200 is not in that list, so that means that this is the answer to number 2. I can't do anything else with it because it's not factorable. And then let's look at number 4. M cubed, that's a perfect cube, and 1 is in the list. So numbers 1, 2, and 4 all can be factored using a sum or a difference of cubes. So I'll do the next step. What does that number 3 mean? It says empty b and empty t. That means once you've determined that you've taken out your greatest common factor and you have all perfect cubes, then you put an empty binomial and an empty trinomial. So for number 1, I'm going to put an empty binomial and an empty trinomial. For number 2, I'm going to put an empty binomial and an empty trinomial. For number 4, I'm going to put an empty binomial, an empty trinomial, and make sure to include my 3 in my answer. Now I know these are going to be finished after I complete that last step, so I'm going to go ahead and box in my answers. And if you want to do these one at a time, it's fine. I just want to talk through them all at the same time. Now, use SOAP. What does that mean? Same, opposite, always, plus. Some people like to say always positive, but always plus. And these are used for the signs of your binomial and trinomial. Now, what do I mean by the same? This sign and this sign, the sign of your given binomial and the sign in the first binomial are the same. So that means I'm going to have a minus sign here. They're the same. Next, this sign and this sign are opposites. So if this is a negative, then you put a positive. And then last, this sign here in this trinomial is always a positive. Now I should have put another step over here. I wasn't thinking. For number 5, you're just going to have to follow what I'm doing over here because it's a lot to write down. Okay, the first thing that you do, take the cube root of each term. And I expect to see this on your paper, the cube root of x cubed and the cube root of 1. The cube root of x cubed is x. That answer goes in the first spot of your binomial. The cube root of 1 is 1. That goes in the second spot of your binomial. Next, I'm going to use some highlighting to help us distinguish. This term here is the square of this term. So I square, I square x. That's what goes here. Now I want you to remember, and we'll encounter that in number 2. If there were a coefficient here besides 1, you also square that coefficient. You square both of them. Okay, the next highlighting I'll do. Hold on. This term here is the square of this term. And I always ignore my sign. I'm finished with my signs. I know what they are. But this term here, the last term of the trinomial, is the square of the second term of the binomial. So then that means I'm going to have 1 squared, which is 1. And please don't put 1 squared. Actually do the math and multiply it out. Now, the last term, this term here, oops, not what I wanted. This term here is the product of these two terms. Multiply them. What is, and ignore your sign again because we know what our sign is already. What is x times 1? X times 1 is x. So that is my answer to number 1. The quantity x minus 1 times the quantity x squared plus x plus 1. Okay, let's go through number 2. We already checked to see if we had the greatest common factor. We don't have one. We already determined that we have perfect cubes, so we can continue. We already wrote an empty binomial and an empty trinomial. Now we're going to use SOAP. Let's go through. Same. So this sign and this sign are the same. This is a plus sign. This sign and this sign are opposites. So this is a plus, that means this is a minus. And then for the last one, this sign is always a positive. So always a positive. Next thing you should do, take the cube root of each of your terms. The cube root of 8 g cubed, and the cube root of 125. The cube root of 8 is 2. The cube root of g cubed is g. The cube root of 125 is 5. So there's my binomial. Now remember, this term here is the square of this term. Let me write that below there so you can see what that means. The square of 2g. 2 squared is 4, g squared. Minus, I'll do the middle term last. The last term, this term, is the square of this one. So 5 squared is 25. That's what I put there. And then for the middle term, remember for this middle term, you multiply these two. 2g times 5 is 10g. That's what I write in the middle. And that's the answer to number 2. Number 3 is finished, and now we're ready to move on to number 4. For number 4, this sign and this sign are the same. Because, let me go through really quickly. We went through and took out our greatest common factor. We already determined that these are perfect cubes. We already put an empty binomial and an empty trinomial and included our greatest common factor. Now we're going to use SOAP. Remember, this sign and this sign are the same. This sign and this sign are opposites. So this is a plus. And this sign is always a plus. Next we take the cube root. So I'm going to write that down. The cube root of m cubed. Make sure I see this somewhere on your paper. And then the cube root of 1. The cube root of m cubed is m. The cube root of 1 is 1. Now, this term is the square of this term. So m squared is m squared. That's what I'm going to write there. This term is the square of this one. 1 squared is 1. So that's what I'm going to put on the end. And in the middle, this term is these two terms multiplied, ignoring this sign. M times 1 is m. So that's what I'm going to put over here. M. And that finishes number 4. If you need more help or need more examples, just reach out to me. I'd be happy to do them for you. What remains in this PDF is your practice for the week. Practice part 1, it says there. There's practice part 2. You'll have your assessment. There's your answers to your practice, your answers to your warm-up for my honors. My regular Algebra 2 will have different answers. And then there's your checklist. I apologize for this mess up here. That shouldn't all be there. I forgot to delete out those things, so I apologize for that. And that's all there is for this week 11. Have a wonderful day.